Good morning, good afternoon, class. I know you're upset that I'm not in there today, but today what we're going to be learning about is 10-6 solving systems of equations. If you're getting organized, I'm going to talk you through this problem here. Obviously, by the end of class today, you're going to learn how to solve system equations. So the first problem is here is we have Antonio, who's making $5 an hour plus $3 for a gas fee every shift. We have Giovanni, who's making $4 an hour, but he gets $11 for gas. What I want to figure out is at what point will they make the same amount of money? So we can do it the old-fashioned way, a little bit in the lesson. You're going to figure out a shortcut for doing this, and you can find out what that point is. So what I need to do is you don't necessarily have to copy this down. Is just start thinking and make sure you're working along with the lesson because I'm going to pause every once in a while. First one, Antonio. Antonio is making $5 an hour and $3 gas fee. So if he works 1 hour, let me think about that. 5 times 1 is 5 plus 3 is 8. So I'm going to put an 8 there. That's how much he's making is $8. After 2 hours, 2 times 5 is 10 plus 3 is 13. I'm going to do one more and then I'll pause and I'll let you finish the rest of the column right there so you can be paying attention. 3 times 5 is 15. 15 plus 3 is, I sure hope you said 18. Okay, I'm going to pause it here for a second. Okay, so hopefully you noticed obviously it was going up by $5 each hour. 8, 13, 18, 23, 28, all the way down to 48. Now what we're going to do is we're going to do the exact same thing for Giovanni. Giovanni this time is only making $4 an hour and $11 plus gas. So if he works 1 hour, 4 times 1 is 4 plus 11 is 15. So he's better off than Antonio so far. After 2 hours, we think 4 times 2 is 8 plus 11 is 19. Okay, and hopefully you're noticing a pattern here because you notice how I went up by 5. Here we're going to go up by 4. So I'm just going to do this real fast here. 23, next one should be 27, the next one should be 31. Scroll down, it's going to be 35, 39. So Giovanni's making a little bit more money right here. Next one is 43, and the next one is 47. Okay, go back. Why did we do all this? When will the two make the same amount of money? If you made a table, you'd find out that at 8 hours, they're making the same amount of money. Okay, now why is this beneficial to you? Because maybe some of you are going to do a calling plan on your cell phones and you want to decide which one's better. Maybe you want to decide between 2 jobs, when is it better? Well, if they're both working an 8-hour shift, it'd be the same. So it's going to go where you want to go. All right, now we're going to start taking some notes here. So we're going to do the first example here. And with the first example, what I want you to do is basically plug in numbers. So we're going to be plugging in numbers and then we're going to eventually be solving these equations. So this first one, determine if the ordered pair is the solution of the system equation below. I hope you can remember this fact, that your first term is your x and your second term is your y. So get in the habit of doing this the first couple of lessons, and after a while this comes second nature to you. So obviously if this is true in both the equations, then it's a solution. If it's not true in both of them, it's not a solution. So what I would do is this one right here is this might look a little confusing. I'm going to focus on A first here. I'm going to rewrite problem here. I'm going to move some things out of the way for us so we get organized. I'm going to go 5x plus y equals 7. So I'm going to write that down. All right, 5. Wait a sec. Instead of an x, why don't I just put the 1 in there? All right, I'll put a 1. And I'll go plus, there's my y, that's a 2. I'll put a 2 there. I'm going to see if that equals 7. Let me check my math here. 5 times 1 is 5 plus 2 is 7. So does 7 equal 7? Yep, that's a true statement so far. So this ordered pair works in that first equation. Now, plug it into the second equation. Once I plug it in there, if it's true, it is a solution. So, okay, let me try this again. Instead of x, I write a 1. And sometimes you're going to get them backwards, but hopefully not. All right, 1 minus 3. The y is a 2, so I'm going to do a 2 Okay, and this is equal to 11. Let's see if this is true. Let me go 1. Well, 3 times 2 is 6. 1 minus 6 is, I think, negative 5. And so I asked myself that real easy question, is negative 5 equal to 11? The answer is no. So what does that mean? Okay, I plugged them in. I plugged them in correctly. The x went for, the 1 went for the x, and the 2 went for the y. It's not a solution. So what's the answer to this one? The ordered pair is not a solution. Okay, what Substitute's going to do right now is they're going to hit the pause button, and you're going to try this problem right here. All right, hopefully you've tried this problem. Hit the play button. So we're going to try this one. We're going to go 5x plus y. So you should be just checking your work at this point. So I'm going to go 5. Instead of an x, I'm going to put a 2 plus, put a negative 3 here. That should be equal to 7. See, 5 times 2 is 10. 10 plus a negative 3. Last time I checked, that's the same thing as subtraction. So I'm going to get 7 equals 7. Hey, it works for the first one. So I put a check. That's a true statement. Now I have to go to this second equation. Instead of an x, I'm going to write 2. So I'm going to go 2 minus 3 times, let me think, what was my y? Negative 3. It's going to look a little confusing there. And that's going to be equal to 11. So negative times a negative is a positive. So that's 2 plus 9. And I think 11 equals 11. So the ordered pair is a solution for this one. First one was not. Why not? These two weren't equal. These were equal, but not these two. So you can't just do it in one equation. You have to do it in both. Okay, this one was a solution because it worked in both. And I showed my work, and I proved it down at the end. Okay, that's the easier problems. That's what your first couple problems today's assignment is going to be like, is just plug them in. What's more difficult is on the next slide. And the ways that we are going to solve them today is with substitution. That's going to be one method. The other one's going to be addition and elimination. Don't worry about it. We're going to be spending a couple days on this one. Okay, here we go. First one, substitution example. What I'd like you to write down is these two equations. The first one is y equals x plus 7. The second is y equals 2x plus 5. As you're writing that down, what you're going to realize is this method's going to work nice when you have a variable all by itself. What do you mean by all by itself? Like this one example right here, y is all by itself here, and y is all by itself here. So instead of moving things around, well, sometimes we will have to move things around. We can do this when the variable's all by itself. All right, this is what I'm going to do. You see this 2x plus 5. I'm going to put it in here for this y. Take this 2x plus 5, put it over here. So I'm going to write y equals x plus 7, my first equation. I know y equals 2x plus 5. Now you're used to y being a number. Kind of work with me here for a second. After I plug it in, instead of a y, every time I see a y, I'm going to write 2x plus 5. I only see one y here. So I'm going to write 2x plus 5. Then I just bring down x plus 7. Okay, what do I do now? Well, let's get rid of the parentheses. That might make it a little bit easier. And we're going to undo some of the prompts. Remember how we've been moving the variables to one side and the numbers to the other side? So when we're done with this, we're going to get the value of x. If I subtract x from both sides, I should have x plus 5 equals 7. Subtract 5, I get x equals 2. So I substitute in for the y, 2x plus 5, and I get x equals 2. Now what do? I plug that into equation 2, I'm going to get the value of y. So your answer is going to be an ordered pair. What's going to happen is these are equations of lines, and where they intersect is going to be the answer. So far we know x equals 2. I'm going to figure out what y is. So go back into that equation that was written in red, the y equals 2x plus 5. So wherever you see a 2, I'm going to write y equals 2 times 2 plus 5. So y equals 9. So the solution is 2, 9. 2 is what we got in the first half. 9 is what we got in the second half. How do I know I'm right? Well, make sure your steps are right. But at 2, 9, if I plug it back into this equation, it's going to be true. If I plug it back into this equation, it's true. So let me try this real fast here, just as everything's trying to sink in. 2, 9. Let me think about that. The 9 is the y, and x is 2. 2 plus 7 is 9. Does 9 equal 9? Of course it does. So it worked in this equation. Does it work in this equation? Let me think. What was the ordered pair again? 2, 9. Sometimes I get a little absent-minded. Put an x here. I'm going to put a y there. So let me think. 2. That goes below here. So I'm going to put a 2. Put 2 there. And then the 5. That needs to equal 9. Let me check my math here. 2 times 2 is 4. 4 plus 5 is 9. Hey, it works in both, and I actually got it right. So I'm substituting when I get the variable all by itself, plugging it in, get an answer for one of the variables. Could be an x, could be a y, and then I plug it back into the second one. Now what's going to happen is we're going to have you try another problem. I'll probably stop the recording and I'll do one more recording after that way, just in case this is taking longer than expected. Okay, here we go. Try this problem right here. X minus 3y equals 13, and x equals 8 minus 2y. I'm going to give you a hint here on how to get started. I'm going to write down x minus 3y equals 13. I already have the x by itself, so what I'm going to do is I'm going to put parentheses there. All right, minus 3y equals 13. Now what the sub's going to do right now is they're going to hit the pause button. They're going to walk around and they're going to make sure that you're doing everything right. And then after I get most of the kids done, they're going to come up here and they'll hit play again, or a student will hit the play. Okay, hopefully you're done with that. First thing I did is I did 8 minus 2y minus the 3y equals 13. And then I just simplified it. Brought down the 8, I combined the like terms. Negative 2y minus 3y. I'm just basically adding those together and I get negative 5y. Now, what I get to do is get the variable all by itself. I'm going to subtract 8. I'm going to get a negative 5y here. And I'm going to get 5. And that's the case that if I divide by a negative 5, I'm going to get y equals negative 1. Once you've got that, then what you should have done is gone back and plugged it into the other equation here. So what I need to do is just get a little bit organized, get everything out of the way for you, and plug it back into the equation. So, or I could probably plug it back into this second one if I want to, because it looks kind of easy for me. So what I'm going to do is I am going to write x equals 8 minus 2y. And wherever I see a y, I'm going to put in negative 1. So I'm going to go x equals 8 minus 2. Put a negative 1 in there. Hopefully I remember my rules here, that this is going to be the same thing as 8 plus 2. And how did I get a plus 2? Negative times a negative, positive. So x equals 10. So what's my answer? Here's my answer. write it in an ordered pair. My x is 10 and my y is -1. And if you don't believe me, plug it back into the original problem. Plug in 10 equals 8 minus 2 times a -1. Okay, both sides are 10. Go back up in here. 10 minus 3 times a -1. That's going to come out to be a +3. It comes out to be 13. That works. Okay, here's where the sub is going to come in handy again. You're going to write down this problem right here. Let me enlarge it a little bit so you can see it. Y equals a -5 minus 2x, and 3x minus 3y equals -3. What do I want you to do? I want you to try this problem. This time, maybe somebody can write it on the board to the side, and then we'll hit the play button and see if we got it correct. So I'm going to pause this, and it's a good time for the sub to pause also. That way the students can work it on the side. I'll have the answers up there for you in a minute. Good luck. And I know the sub will be walking around looking over your shoulder. Okay, now that the sub has unpaused it, hopefully you got the same answer that I did. And I'm going to do this kind of quick because you probably already did this on the side of the board, just kind of reassure everything. All right, the x was already by itself, so wherever I saw an x, I wrote 8 minus 2y, and combine the terms, and I got y equals -1. Once I got -1, you know what, I'm sorry. Just ignore that. Here we go down this problem. No wonder why I had a deja vu feeling with that problem. Y equals a -5 minus 2x. So wherever I saw y in this equation right here, see right here, I wrote -5 minus 2x. I multiplied everything by -3 inside the parentheses right here to -3. Okay, and I came up with a positive because a negative times a negative. And again, positive 6x. When I solve for x, I came up with x equals -2. Now, if you need to slow down a little bit, you can look at that closer. Once I got -2, I plugged it into this equation. Okay, and then again, I did my multiplication first, and negative times a negative is a positive, and -5 plus 4 is a -1. So what's my answer? -2, -1. Okay, I'm thinking this might be a good point to stop. I want to have you practice a couple of problems using substitution. You can always replay some of this and listen to my boring voice if you need to fall asleep. I mean, if you need to understand how to do any of this right here. Good luck. Make sure that you're on task, and got this to refer to if you need to.